So in this video, I'm going to discuss the symmetric swaps problem which occurred in the January long CODECHEF challenge. If you have any doubt regarding this problem, you can ping me up on Instagram, or even you can join my Discord server. I provide both the links in the comment section. I will pin them. So this is the number of test cases, and for every test case you are given a value n and two arrays of size n. You can swap the ith element of a first array with the ith element of second array, such that the maximum of the for the first array, the maximum and the minimum, the difference between them is minimized. Okay, this is what the question basically demands. So for this 1 2 2 1, we can swap this 1 and 2, so that becomes 2 2 and 1 1. Let me focus it. 2 2 and 1 1. So 2 2 2 minus 2 is 0, right? The maximum and minimum both are 2. For this 1 5 3 2 3 1, so what we can do is we can swap these two, so this becomes 2 1, and swap these two, so 3 5, but we don't swap anything, so this 3 1. So the minimum of this is 2 and the maximum of this is 3, so the difference is 1. This is the minimum difference. Okay, this is the minimum possible difference. Similarly for this, you can try it out. So the basic logic behind this code is, let's say you're taking two arrays, okay, ARR and BRR, that is the input arrays. ARR is the first array and BRR is the second array. Then you have to run a loop from I is equals to 0 to I less than n, I plus plus, and you have to find, let's say maximum is equals to maximum of ARR of I and BRR of I. Okay, let's not do it like this. So if ARR of I is lesser than BRR of I, then we are going to swap ARR of I and BRR of I. Okay, this is a very much more simpler, but you can use any other algorithm. Like if the language you are using doesn't give you the permission to swap, then you can use any other, like, okay, so this is the swapping. That is, now ARR has all its element such that ARR of I is greater than BR of I, because if it's lesser, then we are going to swap it, right? So after this position, ARR of I and ARR of I is greater than BR of I for all I possible. Now we are going to make another array. Let's call it combined. Okay, combined, it's a two-dimensional array, n2, and in combined, the thing is that you're going to I less than I and I plus plus, you're going to fill combined with, excuse my handwriting, okay, I of 0 is equals to ARR of I, and combined I of 1 is equals to BRR of I. That is, the first element for every element of row of combined, the first element is ARR and the second element is of BRR. Okay, and the rows are equal to that position of that element in the arrays, respective arrays. So now once we are done with these, we are going to sort the array, okay, CRR based on position 0. Okay, that is based on, like, CRR, if you know how it looks like something like this, okay, like this. So we are going to sort it on the basis of these. Okay, these, clear? So sorry, it doesn't look like this. So whatever it looks like, so we are going to sort it on the basis of 0, the first element, that is on the basis of ARR of 0. Okay, on the basis of ARR. Okay, so once we are done with this, we have sorted it. Now let's say int maximum is equals to what would be maximum? Maximum would be the last element, right? Because it is sorted now, so it becomes n minus 1 of 0. Let me write it clearly. Combined, I'm really sorry, it won't be CR, it would be combined. Okay, combined. So combined int max is equals to combined n minus 1 0, and minimum is equals to combined 0 0. Okay, so this is the maximum and the minimum possible value, and the initial answer would be maximum minus minimum, right? And now we are going to make 4 arrays. Okay, 4 arrays. One array, let's say first min, all will be of size n. Another array will be first max, size n. Another will be last min, and the last will be last max, and this will be first min, first max, last min, and last max, and n. Okay, now what we are going to do in these are, for first min we are going to find out the minimum elements of the first array, okay, of ARR from left to right. Okay, and for first max from left to right the maximum, and last min the minimum of BRR from right to left, and last max the maximum elements of BRR from right to left. I think it becomes a little complex, so if I write the code it will be easier for you. Okay, so first min 0 is equals to combined it would be combined 0 0. Okay, and like first, so, and last min, yeah, so last min of n minus 1 is equals to combined of, combined of n minus 1 and 1, and then first max of 0 is equals to combined 0 0. That is the first elements. We are going to give the first elements, and for last we are going to give the last element, and for last max n minus 1 it would be combined n minus 1 1. Okay, and then we are going to run a loop from I is equals to 1 to I less than n. So in this loop we are, if you notice perfectly, like we are going from left to right, right? So for left to right, as I have already stated, only we are going to deal with only the first, okay, these two. So first minimum we are going to deal with, okay, and first maximum we are going to deal with. First minimum is minimum of first minimum till I minus 1 and combined I 0, I comma 0, and this is maximum of first maximum I minus 1 comma combined I of 0. Okay, similarly like the previous one, and then we run a loop. This was from left to right, and now we are going to travels from right to left. Okay, that is from n minus 2 to greater than equal to 0 I minus minus. Remember one thing, we are not going to mention the first rightmost element, okay, because that is basically the element of the rightmost element. Apart from them we have to, okay, so this will be last minimum of I is equals to minimum of last minimum, over here it will be I plus 1 comma combined I, and now it will be 1 because these two we were dealing with ARR and these two we are going to deal with BRR. Okay, last max I is equals to max of last max I plus 1 comma combined I and 1. Okay, so once we are done with these, we are going to get into the main part of the problem. Okay, so what the main part of the problem is, we run a loop from n minus 1 to I greater than equal to 0, I minus minus. I will in this part I will tell you why we have initialized these 4 arrays and why we are filling it up. Okay, this is the most important part of the whole question. So let's say int we are going to swap. Okay, first of all we are going to swap combined I comma 0 and combined I comma 1. Okay, we are going to swap them, and once we are done with the swapping, if I is equals to 0, then max is equals to last max 0. Okay, and min is equal to, this is for I is equals to 0. Okay, and min is equals to if it's 0, then min should be last min 0. Okay, and if it's not equals to 0, then max would be maximum of first max, that is the first max of I minus 1 elements and the last max of the rest elements from I. Okay, and minimum would be minimum of first minimum elements, first I minus 1 minimum elements and last minimum of remaining elements from I. Okay, and then after this we are going to apply the answer is equals to minimum of answer comma max minus minimum, and finally closing all loops, and we're going to print answer. Only one loop, I guess. Yeah, only one loop we're going to close and print answer. Okay, so this is basically the code. So now what is the basic approach? Let me tell you. We were going to consider this one. Okay, so let's write it down: 4 2 5 1 and 5 3 4 1, right? And 5 3 4 1. So what we are going to do first, we are going to sort this whole thing based on AR of I. Okay, so it becomes 1, then 2, 1 sec. So 1 2, then 4 and 5, and correspondingly 1 corresponds to 1, 2 corresponds to 3, 4 corresponds to 5 and 5 corresponds to 4. Okay, so we are done with this, and what we do, we have to keep ARR the greater. Okay, so if it's lesser, then we have to swap them. It's not lesser, it's not lesser, it is lesser. Sorry, this was lesser. Sorry, so this was lesser, so it would be 3 3 2, and this is lesser, so 5 4, and this it's okay. Okay, so this is the modified whole thing combined. This is what the combined thing looks like. Okay, now we are going to swap elements. Okay, swap elements from right to left. Okay, from right to left. So after the first operation, and we are, for every time we swap them, we are going to check the minimum and the maximum element of ARR. Okay, initially the minimum and maximum element of ARR is 5 and 1, so it is 5 minus 1 is 4. Okay, this is initially answer. So after we swap, so this becomes 1 3 let me write it freshly, 1 3 5 4, because this has been swapped, right? So now the thing is, why did we need these arrays? So if I know from one array, the 4 arrays, from one array I know which is the maximum element among these element and the maximum element among these element, then the maximum of both of them would be the maximum element after this shift has been performed. Like if I am at this position, so I know the maximum element till this position and I know the maximum element till this position. So the maximum of both of them will be the maximum of the whole array after the swaps have been performed from the right. Okay, so 1 3 5 4. So now see which was the maximum element till this 4 and till this it was 5. So what is the maximum now? 5. And what is the minimum? Till this what was the minimum? 4. And till this what was the minimum? 1. What is minimum between 1 and 4? It is still 1. So it becomes 4. So answer doesn't get overwritten. Okay, answer remains 4. Now we are going to swap these two. So now this becomes 4. Now what is the maximum of this? It is 4. And what is the maximum of this? 3. So what is the maximum of both of them? 4. What is the minimum of this? 1. Minimum of this? 4. So what is the minimum? That is 1. 4 minus 1 is 3, right? Now this gets overwritten as 3. So now we are going to swap these two. That is, this becomes 2. So so we are going to consider this and these. Okay. So what is the minimum of this? 1. Minimum of this? 2. And what is the maximum of this? 1. Maximum of this? 4. So 4 and 1 maximum is 4 and 2 and 1 minimum is 1. So that becomes 3. So it is 3. So it doesn't get overwritten. So now we are going to swap these two, right? So after we have, so remember one thing, in this condition, if I is equals to 0, in this condition we don't need to access this array. Okay, this array. So we are going to omit this. We are going to just find out the minimum and maximum of this array. So what was the minimum of this array? 1, and the maximum was 4. So 4 minus 1 is 3. So it still doesn't get overwritten. So what becomes the answer? Answer is 3, right? The answer is 3. You can check it out. So this was the most, like, if you understand this thing, you will get the whole code. If you want, I can run throughout the whole code again for initialize take inputs of two arrays, ARR and BRR. I is equals to 0 to I. So if ARR of I is greater than BRR, then swap them so that ARR of I is always greater than BRR. Then make a combined array. Insert the ARR and BRR into the combined array, then sort the combined array according to the elements of ARR, and then find the maximum of ARR and the minimum of ARR. Then answer is equals to maximum minus minimum of ARR. That is the initially what the answer should be. And then initialize 4 arrays. First min is this array, the minimum of this array. First max is the maximum of this array. Last min is the minimum of these arrays. Okay, this, and last max is the maximum of this array. Okay, from last means from the right to left and first means from left to right. So similarly we operate them. Okay, this is the initialization of all the elements, and this is the operation, this is the operation, and then we go to the final part, that is the loop part, where we swap these elements. Okay, these elements, and then we find out the maximum and minimum of the modified array of ARR, and we find out the minimum possible by making answer is equals to minimum of ARR of answer comma maximum minus minimum, and then we print answer. So the concept behind this is, why do we make the elements of ARR maximum? That is because we know that if the elements of ARR is maximum, then we can make any one element the minimum, because if the minimum element is the maximum and the maximum element tends to be the minimum, that is the condition where the difference, the absolute difference between the maximum and minimum becomes minimized. Okay, to make, like, let's say for if the minimum was 1 and the maximum was 5, then the difference becomes very huge. But if the minimum was large and the maximum was also, and the maximum was as small as possible, it can't, obviously it can't overtake this, but then the difference is 1. Okay, so what we have to do, maximize the minimum and minimize the maximum. If you do that, then that results in minimizing of the difference between the maximum minus minimum. That was the basic concept behind this. This was a very good code. Thank you.